Used to Zoom yelling at me every time. Okay. Um, wow, cool. Speaking of trade and tariffs, there's no data set that's probably more useful than, let me hit share, GTAP. So what I've been working on is getting GTAP into Julia, loaded natively, and it's very close. Actually, this is my big file. It's there. I'm just getting it into a format that's better for the kind of stuff that I'm working on. But so someday, hopefully in the next week or two, I'm able to release this package, GTAP data. It might have a different name. I'll let everybody know. Should also probably make this bigger. Um, and I want to read the GTAP data from sort of native HAR files, stuff that Genpack reads. I don't want to rely on GDX. I'd like to move away from GAMS. It's closed source. And these HAR files will sort of act as a stopgap because Genpack is currently redoing itself. They're rewriting it in C or C++ or something. And I think they're going to use a different file format than HAR, which is going to be great. Because we don't live in the world of tape decks anymore, believe it or not. So the actual thing that I wanted to talk about, I'll show this off. This is just reading a HAR file, believe it or not, har.file. And let's see what it looks like, GSD dat. I don't have this printing nicely because other priorities, but let me look at one of them. Let me just look at the FM. So I try to store as much of the information from a HAR file as possible. Got the har dot header. So the header is just less than 4 characters. It's just the name of the record. These things have metadata, and the metadata includes like the storage types. This is it's indexed. It's indexed by actual indices. It's dense. Has the description of what it actually is, and then it shows the dimensions. So it's 8 by 58 by 140. And I think I actually have the data. The data is just stored as a flat array. It's indexed index comma value. Because this is dense, all the indices are there. Some of these are sparse, so they won't have as many indices. But this is never how we actually use the data. There are 2 options. You can view it as a data frame, and you can view it as an array. So,
quick question.
Yeah.
Just in the flat structure that you showed the data at a single index, but we actually have 3 dimensions. What's the translation?
So this number right here. Yeah. So think of it as you have your.
Oh, it's like 3 arrays that are just.
Yeah. Like you'll have A equals like this. E, right? Like think about these as being your axes. So you've had an index like 1. 1 would point to A, C, because it's the first thing in both.
Okay.
Hold on, I got to do it because I got to remember how it works.
So it's some combinatorial index, and it probably runs index 1 repeatedly, and then index 2.
It goes down columns.
Yeah, okay. Order will come out of there.
Yep.
Okay, that's cool. Interesting.
Yeah. We got a little bit lucky because Fortran is columnar based. It's columnar. That means when you store a multi-indexed array, like a matrix, it goes down columns. So that's how Fortran does it, and that's how Julia does it. If I were loading this in C, it's the transpose.
Right.
So you got a little bit lucky.
We'll
say that again.
Did you have to interpret the indexes, or it was like pretty natural to get into the data frame structure with the 3 dimensions from the flattened version?
That was pretty easy.
Yeah.
Because all I had to do here, I can actually show you the process.
Sorry if this is in the weeds. Some of these just curiosity questions.
No, you're fine. Questions are great because then it slows me down. So I always said to students, and students just sat there and stared at me.
Not me.
So here it is, right? I just did .data to extract that little data thing. So you can see the index and then the actual value. And if I throw this into a data frame, PD, what am I doing? Python? Man, sorry, that PD freaks me out because that's Python, like hardcore. Yeah, basically you're able to take that one and convert it into an actual index. Because the way that the data frame looks
But then
is like
one
that.
represent, yeah, exactly. So that value for like, say, I forget the dimensions of each index. So what's the first index is the 58.
See here, like in this right here.
Like the 3 dimensions, the first dimension is country, so it's like 58 or something. Or no, that's sectors, I mean.
Dimension sizes. So May was asking about AI earlier. There's an example where AI, oh, how do I not have that?
Is theoretically useful.
There we go.
Okay,
And
so
it
the
took a little
first
bit.
dimension is 8.
Yeah, it goes 8, 58, 140.
So the
So
ninth
index
index
9.
should be 1, 1, right? Yeah.
Well, this has 3.
Should 1, 1, 1. 1, sorry, 1, 2, 1. Would that be right? How would that go?
Yeah. Yeah. And if I look at the data frame, the data, this one, 9 is land wheat in Australia. So it goes down all of these, then it goes back to the first and
Back to
it
land.
increments that one.
It's still Australia. Ah, interesting. Yeah, 1, 2, 1. Yeah, that's.
Yep, 1 to 1. Um, that was more annoying than it should have been because I missed a -1 in one little spot, but that's neither here nor there. So here's the data frame. Here's an array. And let me actually get the set info. Oh, let me look at the data frame again. I think it's region, right? Nope, it's production commodity. So for example, X, I could do land, spell it right, PDR, PDR. Oh,
The
I
named
typed,
arrays are only 2-dimensional.
it's only, no, it's 3. 1, 2, 3.
Really? Oh, great. I
Oh,
didn't
it's because the
realize.
last one's a region. I typed in, what did I do? Are they
Is it low?
strings? Let me look at the data frame. Are they strings? Yeah, they're strings. That's what it is. I'm used to using symbols.
Yeah. Symbols are nice. I
There it
didn't
is.
realize named arrays could be 3 or multiple dimensions. That's awesome. I don't know
Named
why I
arrays.
didn't think of that. Yeah, why not? I don't know. I
Named
just
arrays
sort
can
of,
be, yeah, they're arbitrary.
yeah, why not? Fantastic.
So this is the big benefit of, oh, and you can see this number matches that number, which is pretty cool. Off, MGR, pros. What am I looking for here? Grow. So here's the huge advantage of an array, right? You can access things very easily by index. To do the same thing with the data frame, I'm going to have to go
Yeah, it's filter. Painful.
have to subset. What's the first column called? Yao com by row equals off mgr pros. So if you're not familiar with data frames or Julia in general, all I did was took this column and sorted each row so that it equaled this thing. And I could do that for each one. Okay, I'll let AI fill those in so I can just type. Oh, that is awesome. All right. And even then, I don't get the value. I get the row because there could be multiple views. There's not going to be. But in a general data frame, there could be. So that's one of the big disadvantages of a data frame. It can be hard to extract data like that. Like this is a lot more typing than this. And I could write some sort of method to just simulate that, but I think that defeats the purpose of a data frame. So I think most of people are going to be comfortable with the array format. Because like if you have an equation, you can just pull out that specific point anywhere you want to use it. Right? But let's say I wanted to ask a question like how many zeros are there in this set? Or how many zeros are there in this parameter? And there's a lot. There's 14,597. I don't really need those. I could drop those, and I probably will. And I could do the same thing here. It's a much shorter syntax. But what you notice, what's returned here is a lot of true and false things. So it's kind of hard to figure out how many there are just from this. I could take the sum. See, this only gives me the number. This only gives me 14,097, whereas this top one gives me the number and the actual indices. Getting the indices from the array is actually non-trivial. It's less easy, which is unfortunate. Because you might think, sort of what I want to do, I want to do that. So this creates a mask. This creates a mask with little holes cut out. When you hold it up to the array, it just pulls out the ones that you can see. The problem is that it destroys the structure. I just get the index back, like a numerical index back, which is bad.
Well, yeah.
Say that again, sorry.
No, I was just going to say it's just the index. I mean, they're not related to the original data.
Nope, not at all. I mean, that's just how sort of named arrays are implemented. There are other array types in Julia, like a dense axis array. But a dense axis array, I don't believe allows you to do this. It doesn't allow masking. And Julia doesn't really have a good sparse multi-dimensional array structure. They have one for matrices, that's really good, but they don't have one for like n-dimensional things. Okay, so finding zeros, using zeros. Everything in GAMS by default is sparse. So drop zeros. The named array is not sparse, it's dense, but the data frame, just have a lot of characters around. The data frame is. So this is not typically how I would store this data frame. So I wouldn't actually save this data like this. What I would do is I would do my subset, except I would change this to be not equal to 0. Then I just get the non-zero ones. So in this case, it may not be important because there's only going to be like what 64,000 rows, even if I don't have this, if I just have DF. Yeah, there's 64,000 rows. So saving 14,000 rows isn't going to be a huge deal. But some of these, I forget which one, has a couple million rows. So getting rid of the non-zeros in there is actually going to be more important. Okay, so I should stop and ask. Everybody doing all right? I think the big problem with data frames is that people aren't used to dealing with them. Like, May, do you use data frames in your work ever? I get a little nod, that's good. But here's why I like the data frame. And I'm gonna take a different, ooh, that's so small. Why is that so tiny? Okay, here's WiNDC National. I'm not going to build the table because if I do that, it will be a bad idea. And I'm just going to look at the table. I'm just going to look at the raw data. So this is all the data for the WiNDC national model, and it's in a single large data frame. So Eli may have probably seen this before, and they're like, this is neat. And I have this set up so that you could extract different parameters and stuff that's just intermediate demand. But the question becomes sort of, why do I prefer the data frame? Like one question is, why do I prefer the data frame structure? So I arrived at this for a couple reasons, mainly that the household model for WiNDC has different parameters, different numbers of parameters, different name parameters than the national model. Like the entire structure is different. I also have to remember what the indices are, but that's a different issue. With the data frame, it's always going to be the same. Like I have my parameter column and my domain columns, and it will sort of wash itself out. And if you look here, imports is always the same in the column because it's a univariate thing, but that's fine. But how do we model? So how did I solve this for the WiNDC national model? I scroll down to the actual model. So what I did is I created a default dictionary, but let's look at this first. I'm going to look at this. I'm going to close this. I'm just going to make this big. Is it gonna? Oh no, I typed X. That's not an X. It's got to be. Okay, cool. So here's all the data that I need for this production block right here. So this is an MPSGE, but I need intermediate supply as an output, demand and value added are inputs. So I need to extract that data to be able to use it. So the strategy that I took here is I created basically an array. I created a big dictionary. So if it finds the value that I'm giving it, so I'm giving it the row, the column, and I think I changed labor demand and capital demand to value added because it has capital demand. I just want value added. And if the index doesn't exist, it's 0. So I'm kind of using the data frame structure to create what is essentially a sparse array, just a dictionary. And that's exactly what I'm doing. So I'm trying to kind of use the best of both worlds in this case, because an array is just so nice because you can index and you can extract, right? But let's say you're debugging a model. You're debugging the model and you're like, this thing isn't balanced. So one option that you have is so this comes up a lot in GAM. So I have it open here. Now I think I have it open here though. Let me look at WiNDC build for national model. Okay, here it is. Okay. The way to do it is to use 2 VS windows at the same time, right? VS Code windows, just drag it over here. Okay. Sorry, I'm just getting organized. There we go. Okay. This and this are exactly the same. Okay. Hold on, let me every time I'm talking on a camera, I get like 1,000 emails. I don't know what it is. So this block right here and this block are exactly the same. You can see PY, PY, YS0 is intermediate demand or intermediate supply. TY is output tax. And I'm a little bit more verbose than they do in GAMS because I want to be able to read it later and understand it. Yeah, but as you can see, it looks very similar. I'm just pulling out what I need. Okay. I'm trying to think. I had a plan and then I said it somewhere. Yeah. Yeah. So I've done these before. Like one strategy with data frames is that you manipulate it so that each instance there is one row. I tend to like this better. I really like arrays. I wish there was a big sparse array, but there isn't. So I'm trying to think about what I wanted to say. Oh, I got it back. Okay, let's say there's a bug in your code. And the question becomes, is the bug the specification of the model, or is it the actual data inside? Right? So this model is pretty simple. It just has like these right here that you could pretty easily do y as 0, j comma I. Come on. You can do like a summation of these over I. And that has to equal the summation over I of ID 0. Oh, is AI going to do it for me? Yeah, but this shouldn't be there. Something like this. That's the identity that has to be satisfied. And as you get bigger and bigger blocks, this can get harder and harder and harder to do. One big advantage of doing it with data frames and doing it where the data is sort of, I do this and then make my parameter. I can just copy and paste that thing and there it is. So what I can do, come back. This is indexed over sectors. So I can do a group by, a group over the column and the year, then combine. Let me take out normalize use so that the signs are actually correct. And I've done something. Want the index to be the columns. I feel like these should have added to 0, but they're not. Am I doing that? No, it's definitely row. Okay. I had that working. But the point is you can extract the data that you're actually using very easily. Sorry, what was that?
So text should be part of it.
Say it again.
Oh,
the text.
Should you
the
consider
TA,
yeah.
Or TY.
Yeah.
So
y is 0 times 1 minus ty equals to all the inputs added up.
So it's like for I, y is 0 of minus ty of j, right?
Right.
Yeah,
right.
I think that's what I'm missing. What is, hold on, how do I get, oh, because ty starts as a parameter. Let me zoom up to here. ty is output tax. Output stack starts as the output tax. Yeah, that's what's going on. So I'm just missing the output tax rate. But I think if I do that, did I not? Okay. Luckily, I have. Did I do this? It says output tax, right? Did I not do that?
You're just missing a comma.
Thank you. There we go.
Very small, nicely small numbers.
Forget a comma so many times. Okay. So this 1 minus ty is the same as I can sort of get rid of that, right? If I distribute that out and then move this to the other side, this is output tax rate. Output tax rate is the output tax divided by this. So I can just sort of add that back in. Which is cool. So for like A, we're going to seemingly have the same issue, right? Let me look at A. That's this one. X, and of course, why does it not just do case sensitive? Because it's up here.
Love that function.
Give it a second. Okay. And if I get rid of normalized use, so what that normalized use does is just makes everything in use be positive. And I do my group by. This time, I want the rows left over. I always do it by year. And they are huge. What did I do now? Sorry. The point I was trying to make is that these should actually cancel out in the benchmark because you have a reference price in there. So it should have canceled out. Okay, I'll debug them. And the point I'm trying to make is that it's easier to at least moderately extract the data that you care about. Oop. Okay. Does it still have a parse error? Oh, it's down here.
Yeah, because
I missed a parenthesis. Okay. Yeah, I like being able to see exactly what the values are, like at the same time. So I can determine what's going on here. So like I could fix a commodity. So I could do X, subset X, what was that, row. Oh, because I did that. Trusted AI. This is actually one of the interesting ones because it won't always be balanced. This is that I pulled out the perfect one. Yeah, 441 is a commodity that's, what is that one again? I think what I can do is I can do elements of commodity. Nope, I didn't like it. I can just do commodity. And then 441. Why that didn't work? Oh. Motor vehicle parts and dealers.
Oh.
So this is one that tends to be zero quite a bit. And when I look at it here, you can see that in 2009, it's distinctly not zero, and 2010. 2009 and 2010, they are very far off zero. And the reason for that is after the 2008 financial crisis, they were given subsidies, and those subsidies weren't balanced out properly. You can see that in the IO table as well.
But this is calibrated, so what does that mean?
That means that in those years, so it's calibrated in the sense, hold on, let me look at the calibration. It balances out somewhere else, I believe, what happens. Oh, you're fine.
Okay.
Yeah, because this one is, I believe market clearance is doing this. So the problem is that it gets balanced out elsewhere in the table, but that doesn't enter into this constraint because everything else becomes zero except for this one. Because if I look here, it's adding up these. So this is what gross output adds up just by definition. Intermediate supply, household supply, and margin supply. And the problem is that subsidies does not enter this at all. And there's a non-zero subsidy in there. The table actually looks kind of weird.
And the subsidy comes in the endowments. Where is that?
Yeah, it comes in as a tax rate somewhere.
Yeah, should you think?
Let me see.
This
Raw
is
data. Okay. I'm going to make this be unreadable for a moment. By you guys, not by me. There we go. So here's 441. I'll show you what the problem is. Maybe you guys have insight in this, because this is something I've been dealing with. 441, everything is 0. Right there, it's not, but okay, row 35. Click this again. Right here, you see that value? You see that number right there? It's coming from subsidies. It also claims it balances out to 0, which I actually don't know if it does. And if I look here, 2009, that's the exact number. It's the only time that happens. Cool, right?
And so we're looking at
This is the supply table.
This is GTAP, right? So
This
where
is
are we at?
WiNDC National. This is not GTAP.
Oh, sorry, we've moved on a long time ago.
Yeah, no, I'm sorry.
Yeah, that makes more sense.
Yeah, because it's adding up. Yeah, and it does, like, if I do doot, that sum is 0, but it doesn't include subsidies. It's very interesting. Yeah, because the other side of the equation, if I look at the use side, let me go to 2009, 441. I don't need to be too zoomed in. Everything is just 0. There's no use at all.
There's nothing.
Nothing. So that's the problem. Gross output is defined in terms of non-subsidies, because subsidies isn't really an output. So that kind of breaks everything, which is a shame.
So if you run the MPSG version
Not
for 2009, it wouldn't balance.
Yeah, that's correct. And I think I can do that actually pretty easily. If I scroll, and then here I type 2009. It says Y not defined. Where did I define Y? I didn't actually calibrate the table. That's another reason. This will take just a second. Yeah, I have this set up so that it should be able to calibrate any national model that's structured in a similar way. So like Australia we have, all right, there it is, 2009.
By the way, I'm going to present a Center of, did I tell you this?
No.
Center of Policy Studies in November.
Oh, cool.
And we'll talk about the WiNDC then.
That's good. That's cool.
Talk about that. Yeah, I don't know what the sort of value to the world is, but you never know. But let's talk about that.
Wait, why did this give me an error? What? I don't get it. I've run this code 100 times and it never has given me an error before. It's because I'm doing it in front of people. Nope, that one worked.
You weren't recording.
Yeah, that's the problem. So 2023 worked. Why did 2010 work? No, it's the same spot. What, 2011? That's super weird. Did I load up specific data? No. No. What? I don't. So I have it all the years. We'll just see what it does. If it works, it'll solve it. If it doesn't work, it'll tell me what year it didn't work for.
Nice. But it should take a minute.
I picked 3 of the years. So the problem there, so it'll work for literally any year except for the few that I've typed in. That's great. Yeah, so that's the problem with the WiNDC national model. Those 3 years, 2009, 10, and 11 aren't working, and I don't know why. I think it's trying to, oh no, I know what it is. It's because of that subsidy. The tree is unbalanced.
Yeah, that's what I
So
was
you have an
thinking.
you have an output, but you don't have an input. So I can figure that one out. How am I still getting, was that me? I'm on Do Not Disturb. Sorry if you use Google and you keep checking your messages. Yeah, this is mainly what I wanted to do today was get your opinions on data frames versus arrays, because I like data frames, but I know a lot of economists use arrays.
I like array. I like the named array. I mean, you know that already, but
yeah,
I was using the dense access array and then named arrays because of the indexing and filtering is super annoying.
Yep. Yeah, I like data frames because you can, like this code. Let me show you some of Tom's code.
But May, I think
Nothing.
you're going to weigh in, right?
Oh yeah, just go for it. So one of the big things that we do, small numbers are always just sort of a problem, right? So if they're less than a certain value, like, I don't know, 10 to the minus 7 or 10 to the minus 4, we just kind of want to set them to 0. And this whole sheet is Tom's code for dropping small values. So he has to touch every single parameter. And then he's counting the number of non-zeros. Touch every single parameter. Every single time he wants to drop something, he has to like redefine things and readjust. For me, if I wanted to take my big data frame here, my table summary, and I wanted to, I don't know, subset X value by row. I only want the ones that have an absolute value greater than 10. That's going to throw it horribly out of balance because 10 is a terrible number to choose. But it's demonstration, right? If I want to see all the values bigger than 100, what bigger than 1,000? Yeah. I did absolute value because I store inputs as negative. So that's why I did absolute value. But it's very easy to see the big values and the small values, like what actually matters. And I could sort this too. There's the biggest negative, there's the biggest positive. Oh, there's a strange symmetry in there too. Because household supply is just the positive values of personal consumption. Yeah. I've been spending most of my time trying to get that GTAP working, like figuring out exactly what parameters are important. I also have this far more function-based, which you probably saw. Like one thing I can do, this is not necessarily data frame related, but data frames make it easier because you can write things explicitly. If I forgot what Armington supply was, I just typed the question mark in the REPL, Armington supply, hit enter. So it is calculate the Armington for each commodity is defined as the sum of the following. So it's sort of easier to track what you're doing. I also don't carry around that parameter. In GAMS, they carry around like Armington supply and gross output as explicit arrays. I just have it be a function. These things are not CPU intensive to compute. They might be once we start doing bigger things, like maybe like a full GTAP model. But if the data frame is slowing down, you're not going to be able to model it. You're going to have too much data. The model will be too big. So you want to aggregate. And again, aggregation is easy here. You just have one big thing and you go do a group by and a sum. And I think I have a function for it that does it. Like clockwork, 50 minutes on the nose. You teach for that long and it's just, I don't know.
I'm glad you got
All
that
right.
down. Hey,
Yeah, it's
so
not
we
that.
use data frames like primarily in like our work in R, but can you go back to the code in the model in Julia? So so for each function, then you're basically you the first step is you pick the data you want, and then you define the okay.
Yep. I like to be
I mean,
really
the way
explicit about. Sorry, go for it.
Well, no, I mean, like the way you've been working through it, like it's incredibly handy, and I like how you can quickly like potentially debug and see the numbers. Like that's incredibly handy and much easier than in GAMS, which is nice. I can see this though if you're trying to like read a model and you have your model, it'd be like I don't like the data tables that are sort of clunky because I just want to look at the model now that I know my data is right. But yeah, this looks
What I would actually want to do, if I comment all this out. Oops, that's not the right.
Just nest it.
No, I would have a function. So this would be
okay.
Like Y production block. That's a terrible name. Don't use that name.
Right. But you can just have that, and that makes sense.
And then this would be a function with a doc string. So let me look at this right here. This, whatever is above a function, this is a doc string. And it's really powerful because I can do calibrate constraints. Uh-oh. Oh, that's going to be, oops, missed the L. There it is. So this becomes right here. And it's internal because the end user doesn't use this, just within the package they use it. So you can actually see what's going on where. So you can discuss exactly what that data is. After you have it right, it doesn't matter. Because you can just make it be a function with the doc string.
Yep. Oh, that's great.
Yep. Yeah, I found it much easier to debug. That says more about GAMS, really, but also if you don't know, if you're not using VS Code and you're wondering how I'm doing this, I just hold Control Alt and then up and down on the arrow keys. You can also hold down the middle mouse button and just drag.
And then does everybody know the multiple select? It's my very favorite.
Like he's talking about this. See how all the
Yeah,
productions are
Control D.
highlighted?
It's
Yeah.
like a
Eli told me
find,
this.
but instead of going individually, you can just go as many, however many you want and edit them all at the same time.
So what's the code for that?
So,
The shortcut is
did-
Control D.
yeah.
Control what?
So
You select the characters that you want to find. There you go.
yep. So I'll select A and hit Control and D.
And so if you
Oh,
it's
that's
in order,
great.
so if you didn't want that last A, you could have not included that. You can manipulate them however you want all at the same time, delete them, start again, go to the end of the row. So good.
Yep.
All right. Well, that tidbit was worth my time today.
Yeah, I know.
It's a really
So
good
this-
one. It's so fun.
Try to do some sort of value every time.
No, this is great.
Yeah.
I got
Eli showed me that.
double the value in this case. One trick and a lot of interesting stuff.
Yeah.
Hey, quick question on MPSG. Tom, I know had been working on like version 2. Did that ever get released, or is that like that'll just never happen?
I doubt it. Yeah. So I might have some code. He sent me code in the past that did what I wanted it to do, and I said you should put this on GitHub. And then he retired. Somewhere. Oh, I bet it's on my other computer. Somewhere I have
Do we
code
think
that does
he's
it.
like?
Sorry, go for it.
No, I was just speculating on what he's up to. If he's dancing or taking long train trips or
Ping pong game.
ping pong.
Yeah.
He does
Yeah.
have a lot of interest. Oh, the electric bike, I believe, was one of the. What he's
Yeah.
not doing is responding to emails, I've noticed.
Let me see.
But if you enter a ping pong tournament in the Madison area, you might get
I'm
a chance
ready to
to.
do
Is that
that, yeah.
right?
Maybe. Or a Scrabble tournament. He was doing Scrabble for a while there. Oh my goodness, I found it. Let me share my screen one more time here. Oh dear, that was terrible. I open this.
I guess another question for you, Jim, is like, what about the version 2 was particularly interesting, and can we do it in Julia?
I thought I can't honestly recall, but I thought that he was developing some nice functionality, and I can't remember what exactly. Maybe it's for like debugging or something like that. It was going to write out the equations in straight games. Maybe that was it.
I think the equations was one of them that I recall.
That didn't work.
So-
Yeah. If I could actually open the correct folder. It's on my other computer.
Conveniently labeled other computer.
Yeah. That's a Google Drive thing.
Oh, okay.
It's actually the work computer. WiNDC, MPSGE version 2. Let's just look at all of them. Let's see if it actually runs. Yes. Okay. What do you think the main file is? Probably this, no?
Yeah.
Okay, if you memorize all of this, I think it's the code that does it. Oh my goodness, Tom. Yep, this will be it. So this is what he had. And I bet. Let me see. Let me look at this one too, just to be sure. Okay, cool. See if I can run it. Oh, my computer is suddenly running very slow. Yeah, it's using 90% of the CPU. What's going on? Oh, it's Teams. Hey, wouldn't you know streaming slows down your computer? Nobody would have guessed. CD M22, GAMS M22.gm. So now it's doing something. A lot of errors. Oh, that's not great.
What if can you look at the PDF? Yeah.
Yeah.
Because that's from a previous.
Yeah, so this is what he's generating. Sectors, commodities, consumers. And then This is the part that people want, right? Because this is the machine or like a human readable aspect to it.
Yeah.
Yeah, and this I'm working on building into the Julia part, so it's actually pretty. But I think all of this is just sort of him manually doing it. I go over here. I think that's what all this code is.
So I guess I was under the impression he was going to release like new was it like Fortran code or something like that, and push that to GAMS, and like whenever you like updated, then you would like have all these features.
Yeah, I think he was going to do it in more GAMS centered because he wants to be able to generate this stuff automatically, which he might do with Fortran. Yeah, that was always on his project list. And then he retired.
All right, so odds are that's not going to happen, which that's okay. We'll just do it in Julia.
Yeah. If you want, I
All right,
can
well,
send you this
I have to hop
stuff.
over to another meeting.
Okay, cool. Oh yeah, it's
All right, great
probably.
seeing you. All right, bye everybody.
Yep.
Good to see you.
Hold on, I should stop sharing and stop recording. Stop.